In this video, we will be discussing about maximum average pass ratio. There is a school that has classes of students and each class will be having a final exam. You are given a 2D integer array classes where classes of I is equals to pass comma total. You know beforehand that in the ith class there are total students, but only pass I number of students will pass the exam. You are also given an integer extra students. There are another extra students that are guaranteed to pass the exam of any class they are assigned to. You want to assign each of the extra students to a class in a way that maximizes the average pass ratio across all the classes. Return the maximum possible average pass ratio after assigning the extra students. Answers within 10 to the power minus 5 of the actual answer will be accepted. So what they are saying is that in the input, we are given a 2D array and we are given another integer which is extra students. Now here, each of the pair is denoting that these are the number of students that will pass in a class which is having total number of students as 4, right? So there is a class where the total number of students are 4 and the number of students that will pass in that class will be 2, right? Now these extra students that are given to us, these students will always pass the exam, right? Now we need to assign all these extra students to these classes in such a way that we maximize our average pass ratio. Now first of all, what is the pass ratio of a class? So the pass ratio of a class is equals to the number of passing students divided by the total number of students in that class. So for this particular case, it will be 2 by 4. So whatever this value will be, 0.500. So this will be the pass ratio for this particular class, right? Similarly, we will have for all other classes. Now, whatever will be the average of that pass ratio that we need to maximize. So these extra students have to be assigned in such a way that we maximize the average of the pass ratio of all these classes, right? So now how are we going to do this? So let's think of a greedy approach for solving this. So see, initially, what are all my values? The first one is 2 by 4, right? I will try to find out the pass ratio for each of the class, right? So it is 2 by 4, 3 by 9, 4 by 5 and 2 by 10, right? What is their pass ratio? It will be 0.50000. So since it is said that answers within 10 to the power minus 5 of the actual answer will be accepted. So I am writing 5 decimal places over here. 3 by 9 will be 0.33333, right? Then 4 by 5 will be 0.80000, right? And 2 by 10 will be 0.20000. So this is what the pass ratio is right now. Now, if I try to assign one extra student to each of these classes, then let me see what change is it going to make, right? So see, whenever I am adding one extra student, and that extra student is always going to pass, so my passing number of students will increase by 1 and my total number of students will also increase by 1, right? So what I am saying is I will take one extra student and I will check that what is the impact that it is creating when I am adding to any of these classes. So if I add to this class, then this will become 3 by 5, right? This will become 4 by 10, this will become 5 by 6, and this will become 3 by 11, right? So now if I try to find the new pass ratio, so 3 by 5 will be 0.60000, right? 4 by 10 will be 0.40000. Then 5 by 6 will be 0.83333, and 3 by 11 will be 0.27273, right? Now, if I try to find the difference or basically the delta of these pass ratios, meaning what is the change that we have got after adding one extra student to that class. So see, this minus this will be 0.10000, right? Then we will subtract these. So it will be 0.06667, right? Then what will be the delta here? 0.03333. And what will be the delta here? 0.07273, right? So these are basically the deltas, right? That when I am adding one student to each of these classes, then what is the change in the pass ratio of those classes, right? So for this class, the delta is this much. For this, the delta is this much, right? So now, which one are you going to consider? Should we consider this one? Why? Because this is the largest delta that we are getting. This is 0.1, 0.06, 0.03, 0.7. This is the largest delta that we are getting. Then that means when I am adding one student in this particular class, then this class is giving me the largest delta as compared to the other classes. And if I am getting a larger delta, then that means it will be contributing more towards increasing my average or maximizing my average, right? So that is why for assigning the first extra student, I will assign it to the first class because it is giving me the largest delta, right? So in this particular class, we will be assigning our first student, right? So this was for first student. So now when we have assigned one extra student to the first class, so now the passing students will become 3 and the total number of students will become 5, right? So for the next student, the values are 3 by 5, 3 by 9. Others will remain as is, right? Because the first extra student I have assigned to this class, so others will remain as is. So it will be 3 by 9, 4 by 5, 2 by 10, right? Now what will be their values? So this will be 0.60000. 3 by 9 will be 0.33333. 4 by 5 will be 0.80000 and 2 by 10 will be 0.20000. Now if I try to add in these, right, let me just separate these ones. So now if I try to add 1, so this will become 4 and 6, this will become 4 and 10, this will become 5 and 6, and this will become 3 and 11, right? Now what will be the new pass ratio? So this one will be 0.66667, right? Then 4 by 10 will be 0.40000. 5 by 6 will be 0.83333. And 3 by 11 will be 0.27273. Again, let's find out that what is the delta that we are getting. So for this, it will be 0.06667, right? For this, it will be 0.06667. Again, here it will be 0.03333 and here it will be 0.07273, right? So this is the delta that we are getting. Now which is the class that is giving you the greatest delta? This one, right? This is 0.06, 0.06, 0.03 and 0.07. This is the largest delta. So we will add the second extra student to this class, right? So now for the next student, the values will be 3 by 5, 3 by 9, 4 by 5 and 3 by 11, right? Again, let's find out the pass ratio. So 3 by 5 will be 0.60000, 3 by 9 will be 0.33333, 4 by 5 will be 0.80000 and 3 by 11 will be 0.27273, right? Then if we try to add it in all of these, this will become 4 by 6, this will be 4 by 10, this will be 5 by 6 and this will be 4 by 12. Now what will be the new pass ratio? This will be 0.6667 or we can say 67, right? This one will be 0.40000. This one will be 0.83333 and this one will be 0.33333, right? Then let's find out the deltas again. So this one will be 0.06667, right? This one will be 0.06667. This one will be 0.03333 and this one will be 0.0606, right? Now which is the maximum delta? These two are the maximum ones, right? So we can take any of these. So let's suppose that I took this one, right? So now this was for the third student and we have assigned it to the first class, right? Now what will be the values for the next student? So first one will become 4 and 6, second one will be 3 and 9, 4 and 5, 3 and 11, right? Then what will be the pass ratio? So it will be 0.66667. This one will be 0.33333. This will be 0.80000. This will be 0.27273. Then if I add the student to each of the class, this will be 5 by 7, 4 by 10, 5 by 6 and 4 by 12. The new pass ratio will be 0.71429, 0.40000, 0.83333 and 0.33333. So now what are the deltas that we are getting? So this one will be 0.04762, This one will be 0.06667, this will be 0.03333, and this will be 0.06060, right? So now which is the greatest delta? This one, right? So the fourth student will be assigned to this class. So now the new values are 4 and 6, 4 and 10, 4 and 5, 3 and 11. So after assigning the four extra students, this is what our passing student and total students for each class looks like, right? Now what we can simply do is that we can find out that what is the average that we are getting. So first, let's find out the pass ratio for all these. So this will be 0.66667, right? Then this one will be 0.40000. This will be 0.80000, and 311 it will be 0.27273. So what we will do for finding out the average, first we will sum up all these values. So this will come out to be 2.13940, right? And now for finding out the average, the total number of classes that were given to us were 4, right? So we will divide this by 4. After dividing it by 4, the value that we will get is 0.53485. And this is the largest average pass ratio that we can get, right? So this is the greedy approach that we have followed, that for each extra student, we are identifying that which class is giving the largest delta. Whichever is giving us the largest delta, we are assigning that student to that particular class, right? So code wise, how are we going to implement this? So see, what we can do is that we can identify that if I assign one extra student to each of these class, then these are the deltas that I am getting, right? Now at each point, right, for each extra student, I want that what is the largest delta. Basically, I want the maximum value out of all the deltas, right? So what I can do is that I can maintain a max heap, right? Via max heap, because that will always contain the largest value on the top. So what I will do is that I will give all of these delta to my max heap, right? And along with these values. Why these values? Because if I will only give the deltas, then I won't be knowing that which delta belongs to which class, right? So this delta along with this information, we will push it inside max heap for all the classes, right? Then since this one was the largest delta, this value will be present at the top, right? So you have identified that, okay, the first student I will be assigning to this class, right? So what you will do, you will take out this value from the heap, right? You will pop it from the heap. And now since this delta was for 2 by 4, but now this 2 4 has changed to 3 5, right? So now we need to identify the new delta, right? Basically 2 and 4 has changed to 3 and 5 now, right? So now for giving the next student, for assigning the next extra student, it will become 4 and 6, right? So now you will identify what is the delta for these. So this is the delta, right? So now when we popped this value out from the max heap, so for this, now we will push the new delta along with 3 and 5 into our max heap, right? And when we will do this, then this will be the maximum value that we will be getting. So now this was corresponding to 2 and 10. So this 2 and 10 will now be changed to 3 and 11, right? So now for 3 and 11, we will try to find out that what is the delta that we are getting. And in the max heap, again, we will push this delta along with 3 and 11. Same process we will follow for all the extra students that we want to assign, right? And at the end, what we can simply do is that when we have assigned all the extra students, then whatever are these values corresponding to the deltas, whatever are the values that we have stored, we will take them, we will identify the pass ratio, we will do sum of all of them, and then we will divide it by the total number of classes, and we will be able to get our answer. So this is how we are going to solve this problem. So let's quickly look at the code. So first of all, since we want to create a max heap, and in C++, max heap is implemented using a priority queue. So we will create a priority queue, right? And in this, I want to store the delta as well as the number of passing students and the total number of students, right? So what I will do is I will take a pair. In this pair, the first value will be my delta, right? Which will be a double, right? And the second value will be again a pair in which I will store both the number of passing students and the total number of students, right? So this is how my max heap will look like. So basically in my max heap, if let's suppose this is the case, so I will be storing a pair and it will look like 0.04762 comma again a pair 4 comma 6. So this is how I will be storing in my max heap, right? So now what are we going to do is that we will identify the initial deltas, that if I give the first extra student to each of the classes, then what is the delta that they are giving, and those deltas along with the class information, we will push it inside our priority queue, right? So for finding out the new delta, let's create a function so that we can use it again and again. So this will return us a double value, which will be the delta, right? Let's name it helper. So this will receive the number of passing students and the total number of students in the class, right? So for finding out the delta, we will do pass plus 1, right, divided by total plus 1, right? This is the new that we will get, minus pass divided by total, right? And since these are integer values, we will cast them to double, right? Here also we will cast it to double, right? So through this we are identifying that what is the new delta. So these were the original values and these are the values after adding one extra student to the class, right? So this will give us the delta. So now here what we will do is we will run a for loop that for auto class in classes, right? We cannot write exactly class spelling over here because in programming languages class is a keyword, right? See, class is a keyword, so we cannot write class over here, otherwise it will give you error. So now inside our priority queue, what are we going to push? We need to push a pair, right? In that pair, the first value is the delta we will identify using the helper function. Inside this helper function, we need to pass the number of passing students and the total number of students, right? And then the second thing is a pair in which we want to store that how many passing students are there and how many total students are there, right? So this is what are we going to push inside our priority queue, right? Now that we have initialized it, now we will assign each of the extra students, right? So while extra students minus minus, right? So this loop will run equal to the number of extra students that are given to us, right? Now we will take the one which is giving us the maximum delta, which will be present at the top of our priority queue, right? So we will take auto. This will give us the gain, or we can say the delta, right? And the info of the class, right? This will be present in pq.top, and then we will pop it from our priority queue, right? Now the number of passing students are info dot first, and the number of total students is info dot second, right? Now we need to find out that what will be the new delta when we have added one student to this particular class, right? So inside our priority queue, we will again push. So now the new delta will be, now what will be the values? The values will be pass plus 1 and total plus 1, right? Because now we have increased it to 1, right? Or what we can do is that we can do a plus 1 over here, right? Because in this particular class we are adding a student, so now we can say the new number of passing students is this and the new number of total students is this. So we will pass this passing and total students inside our helper function and it will give us the new delta, right? And then the second value will be again number of passing students and the total number of students, right? So this is what we are going to push inside our priority queue. After we are done assigning all the extra students, we need to find out the average, right? So first let's find out what is the sum that we are getting for all the pass ratios. So we will create a double variable named ratio sum. We will keep it 0 initially, and then we will do that while the priority queue is not empty. What you do? Take the top value. So this will give us the delta and the info. Delta we don't need as of now, only we need info, right? So this will be pq.top and we will pop it from our pq, right? So in the ratio sum, what are we going to add? Passing students divided by total number of students, right? So it will be info dot first divided by info dot second, right? Now at the end we can simply return ratio sum divided by the number of classes, which will be classes dot size, right? So let's run this code. So now in this, if you see, we are running a for loop in our classes, right? And the classes length, if let's suppose is n, so we are pushing all of these values inside our priority queue, and the size of our priority queue will also be n, right? So pushing operation will take log n time, so this loop will be taking n log n time, right? Then here we are running a loop for the extra students, and inside that we are again pushing some values in our priority queue. So this pushing operation will take log n time, and if we consider extra students as k, so this loop is running k into log n time, right? And then here again, this while loop is running while the priority queue does not becomes empty. That means n times. And inside this, we are doing the popping operation, and also this will again take log n time, right? So basically, the time complexity over here is order of n log n, right? Plus k log n plus n log n, right? Simplifying this, we can say that it will be order of n plus k log n, right? This will be our time complexity. Then what will be the space complexity? So we have taken a priority queue inside which we are pushing the information for all the classes, right? So this will be equals to the size of the classes, that is order of n, right? So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.